Okay, in this question, number 29, we have a sector. So that's a part of a circle shown here. And it could be, so it's a sector because it's a part of a circle. So there's the rest of the circle. That forms the lateral surface area of a right cone. The lateral surface area of the cone is 20 pi square meters. Alright, so the area of this part right here is 20 pi. Use the formula for the area sector to find the slant height of the cone. Now first, why is L the slant height? If we took this and like curved it, like so if we had it cut out and we folded it, we could fold it to form the lateral area of the cone. Where now like 150 isn't really there, but the slant height would be there. And then this base is that's the base of the cone. So we could find L by using what we know about sectors. All right, 150 degrees over 360 represents this part of the circle over the whole circle. Equals the area, 20 pi, over the area of the entire circle, if I were to extrapolate that like that. Now, the reason why that's important to find is because then we can use it to find the radius, because we know that area is pi r squared. Alright, so now we're going to solve this for r. Alright, so instead of writing pi r squared, we can also just put in x. Alright, and then we're going to cross multiply and solve for x. So when we cross multiply, we get that x is equal to 150.72. And x represents, since it's on the denominator with 360, x represents the area of the whole circle. So we could set that equal to pi r squared, and then divide that by pi, and we get 48 equals r squared. So the radius is going to be, if you take the square root, you can approximate it as a decimal, or simplify that as 4 root 3. Alright, so 4 root 3 would be the radius of this whole circle here. So it's also the slant height. Okay, so now I rewrote this r. I crossed off r and wrote it as L, because yes, it is r, the radius of this circle here, but when we take this sector and we like fold it into a cone, like this length here is L, it's the slant height of the cone. R is the radius of the base. So to find that, we're going to use the lateral area formula for a cone. And we know that the lateral area is 20 pi. We know that L is 4 root 3. And now we're going to solve for R, which would be this radius of the base. That's what that would represent in the cone formula. Alright, so if we solve, we get 20 pi is equal to pi r times 4 root 3. Alright, divide both sides by pi, and we get that r is equal to 20 over 4 root 3. So that, if we just put it as a decimal, we're going to get is 2.88. So this radius right here is about, we'll round it up to 2.9. Alright, L is 4 root 3. So now we could use the Pythagorean theorem here to find the actual height of the cone. So we would do h squared plus 2.9 squared is equal to 4 root 3 squared. And then if you just do 4 root 3, if we solve that out by doing 4 root 3 squared and then subtracting 2.9 squared on both sides and then taking the square root, we get that the height is equal to about 6.3.